This video lesson is all about understanding what coordinate system is, why do we need to study about coordinate systems in data science or let's say in machine learning, and what are the different application areas. Essentially, what are the concepts that we can start learning more easily once we know what coordinate systems are. I'm recording these videos for absolute beginners, especially for learners who have not studied mathematics in their 10+2 or let's say in graduation, and that is where I'm trying to break down these videos and trying to make them as simple as possible. If you're not familiar with what number lines are, I would recommend you to visit a previous video lesson which I have recorded just before this. Just to give you a preview, this is the example that I've taken. Feel free to revisit this, just brush up the concepts and come back. Let's resume the lesson for today, which is the lesson on coordinate system. For your reference, I'm going to provide some of the application areas. To start with, coordinate systems become a base. They are laying the foundation of something called as coordinate geometry. And in this field of mathematics, you get familiar with objects like lines, planes, and hyperplanes. Once you're comfortable with coordinate systems, you can start plotting functions, which is where you can visualize functions dependent on a single variable or functions that are dependent on multiple variables. In some form or the other, coordinate systems are actually used while visualizing data by creating appropriate charts. So you would see coordinate systems being used in scatter plot, both 2-dimensional and 3-dimensional, as well as in line charts too. While explaining the working of many of the machine learning algorithms, we do use coordinate system. I provided here some of the examples, which are the areas or the machine learning algorithms where coordinate systems are actually talked about. Similarly, in deep learning also, when it comes to visualizing activation functions, we do talk about coordinate system, and there are more such areas. Let's start the lesson and let's start understanding first what is the real need of having a coordinate system. To make this relatable to a real world example, I've taken Jeff, a person, and his two attributes, age and work experience. We know the values of these two attributes, and based on our current knowledge, we will probably rely on using two different number lines. As you can see, the values are 40 for age and 20 for work experience. That's where the 2 points are showing on the respective number lines. Now there is a challenge, which is we are using two number lines to represent a single entity. The entity here is a person, and in other examples, a single entity could be either a movie or let's say a song. And the corresponding attributes could be, let's say, movie name, movie rating, movie director, year of release. Similarly, for song, it could be song name, the band who created the song, and the song genre, etc., etc. Now, to overcome this challenge, we need to think of something more simpler, and we need to combine both these number lines into a system, and that system is the coordinate system. The reason these two number lines will not do here is because they will only complicate the matter. For example, if I add a third attribute for this person Jeff, then the number lines will increase by 1. This will become even more complicated when I consider one more person or let's say one more entity and try to do some interaction, let's say a distance computation between two entities. That's going to be a nightmare. So this is clearly not a scalable approach, and we need to move to something more simpler, which is where coordinate systems come. So the clear need is to have coordinate system. Let's define that. We are going to use both these number lines, but they will be placed together and in a certain orientation, which is 90 degree or being perpendicular to each other. Notice that I'm calling this vertical axis as work experience and the horizontal axis as age. And you can actually swap the two. It does not matter for this example out here. Do also notice that I'm calling this vertical axis with the capital Y label, and the horizontal axis with a capital X label, which is the normal convention used in coordinate systems. Now the objective is to have a single point somewhere in this space that represents Jeff. Why? Because we have two different locations while we were using number lines. Now the problem has become to locate that single point somewhere in this space. We'll take a step-by-step approach to do so, and we'll start with the coordinate or the position of point with respect to the age attribute. Do notice that the age value is 40. Thus, we need to find a location of the point where the age value is 40. And there are multiple such possibilities. And for that, refer to this vertical line. Notice that all the points that will fall on this line will have the age attribute value as 40. Let's now consider the other attribute, which is the value 20. Similar to this, we can consider a horizontal line wherein the work experience value is going to be 20, and similar to other multiple points earlier, we can have multiple points which have the work experience value as 20. Now, the only place where both these lines intersect is this region, and that becomes the point of interest for us because that's where the entity, which is this person Jeff, lies. Notice that at this point, the values are 40 and 20, which are the coordinates for age and work experience respectively. While writing the coordinates, we follow a certain order. We put in parentheses or round brackets the value of the x coordinate first and the y coordinate after. So out here we have seen the example of how two-dimensional coordinates work, and we have to have two attributes to define that. And for you to locate, let's say, a single point anywhere in this space, you need to have both x and y values. Let's say for any point randomly selected, you need to have both the x and y coordinates for you to really locate this point out here. Similar to a two-dimensional coordinate system, we have three-dimensional coordinate system, which can be expressed or which can be described by adding, let's say, a third dimension, and this is commonly denoted by capital letter Z. And for our person, Jeff, you can imagine a third coordinate or a third attribute, let's say salary or monthly income, and then you can place Jeff in this 3D coordinate by considering all the values for first, second, and let's say the third attribute if it is somewhere here. We'll probably discuss about 3D coordinate system in a separate lesson. For now, let's look at how to really plot points in a 2D coordinate system using, let's say, an online plotter. In fact, before even going there, let's understand how the number lines, which are the vertical and horizontal axis, divide the coordinate system into four parts. So we have this horizontal axis x and the vertical axis y, and they are dividing this overall two-dimensional space into four parts. Let's consider this first part. It's also called as quadrant 1. And notice something unique about this quadrant, that all the points that fall here have to have both x and y values positive. Why? Because we are talking about this region, which is on the right hand side of this center point 0. It's called as origin. And we are talking about this region, which is again all positive. Similar to the first quadrant, we can have a look at the other quadrant. This is quadrant number 2. And something unique about this quadrant is here all the x values are negative, because now we are talking about this other side of the x-axis, the horizontal axis. So x is going to be all negative and the y values are still going to be positive. So to denote this second quadrant, you can write in parentheses minus and plus. For first quadrant also, let me write the same, which is plus and plus. On similar lines, I'll just write For the other two quadrants, what's the convention? This is minus and minus, because both x and y will take negative values, which is all the points in this quadrant. Similarly, for the last quadrant, you will see positive values for x-axis and negative values for y-axis. Why? Because we are talking about this region now, and the y-axis values are going to be negative, whereas they are going to be positive for the x-axis. This basic understanding helps you tremendously as you move on to slightly more complicated concepts such as lines and also scatter plots. Let's now quickly spend a minute or two maybe on the online platform GeoGebra that I mentioned earlier, and let's plot a couple of points by using their two coordinates. What you see here is a platform, a website called as geogebra.org. It's a very powerful online platform where you can learn basics of mathematics and you can actually take it to a more complex and higher level. For now, let's just restrict our interaction with this platform to plotting points in two-dimensional coordinate system. So I'll go here, which is Start Calculator. And this will take me to this page, which is calculator suite / calculator over here in the address bar. And there are multiple options. I can actually go and plot 3D graphs as well. For now, I'll just keep the graphing option selected. And it does show me the 2D coordinate system that I showed you earlier as well. And you can zoom in, you can zoom out, you can play around a bit. The center part wherein both the vertical and the horizontal axis intersect is called as origin. And for me to plot, let's say, a point in this interface, I need to specify the x and y coordinates of that point. So I'll use the attribute values for the entity we consider, which is the person Jeff. And using this section, I will feed my input by placing the coordinates in parentheses or round brackets. I will write 40, 20 and hit enter. Notice this point appearing at the appropriate location. What I can also do is give this point a specific name. You can notice the letter A, which comes by default, and I can change this to, let's say, Jeff. Do also cross check at your end that the coordinates are correct, which is 40 and 20 respectively. You can plot one more point. Let's call that as Mark. I will write the expression and provide the coordinate values. Let's pass that as 35 and 10 and hit enter. So you understand the basics now, which is the system, the way it works. The number lines, how they are represented. They are rather called as axes now, the vertical and the horizontal axis, which is y and x respectively. And using the coordinate points, you can start putting the points together. Once you start putting multiple points in the system, you can start talking about the basics of concepts like coordinate geometry, wherein lines come, wherein other shapes like circles and parabolas come. You can also talk about visualization, which is scatter plot. You can start observing relationship between variables and also start showing trend lines, for example. And then you can further move to machine learning concepts, start visualizing linear regression, the way errors are distributed and all that. And then also talk about k-means clustering, the way it works, the underlying phenomena, which is based on distance measures, how clusters are formed. So coordinate system is something very basic, but it is very handy in terms of understanding some of the more advanced techniques that I talked about.